Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Researchers have discovered a process that can contribute to the melting of ice shelves in the Antarctic. An international team of scientists found that adjacent ice shelves play a role in causing instability in others downstream. The study, led by the University of East Anglia in the UK, also identified that a small ocean gyre, a system of circulating ocean currents, next to the Thwaites Ice Shelf can impact the amount of glacial meltwater flowing beneath it. When that gyre is weaker, more warm water can access the areas beneath the ice shelf, causing it to melt. The Thwaites Ice Shelf is one of the biggest ice shelves in West Antarctica and buttresses the eastern side of the Thwaites Glacier, which has been retreating rapidly over the last 20 years and is the largest contributor to global sea level rise among Antarctic glaciers. Most of this warming was driven by waters with a high volume of glacial meltwater originating from the Pine Island Ice Shelf, further east, flowing into the area beneath the Thwaites Ice Shelf. The glacial meltwater mixes with saltwater when the ocean melts the base of ice shelves and can form a buoyant layer of water that is warmer than the surrounding waters. This lighter, relatively fresher and warmer water brings heat that melts the base of the Thwaites Ice Shelf. However, in this study, we show that a great amount of heat at shallow layers beneath one ice shelf can be provided by waters originating from other melting ice shelves nearby. Therefore, what happens to one ice shelf can impact the adjacent ice shelf, and so on. This process is important for regions of high ice shelf melting such as the Amundsen Sea because one ice shelf sits next to the other, and the export of heat from one ice shelf can reach the next one through the ocean circulation. Dr. Dotto added, "These atmosphere-sea ice-ocean interactions are IM." For more than a year these sensors sent, via satellite, the data used to identify the ocean variations. For example, how the temperature and meltwater content varied. From these observations, the researchers suspected that the excessive heat could not have originated locally at the Thwaites Ice Shelf because they did not see strong melting at the sites where the sensors were installed. By combining the information with computer simulations to identify the origin of this heat, they found that the water that leaves the Pine Island Ice Shelf can access the areas beneath Thwaites Ice Shelf. The mechanism that explains how these waters access the Thwaites Ice Shelf was identified by using model simulations and data collected by tags attached to seals. They both showed that a gyre near the Thwaites Ice Shelf weakens in winter, which allows more heat to reach shallow areas beneath the ice shelf. Satellite images also showed that the Southern Hemisphere summer season of 2020-2021 was unusual because it had a high concentration of sea ice in regions near the Thwaites Ice Shelf. Drawing on the simulations and previous research, the team hypothesized that the gyre was even weaker, so the excessive meltwater from adjacent ice shelves could not be moved away from that region by the currents and instead entered the Thwaites Ice Shelf. This reduced even more the strength of this gyre, which enabled the inflow of water with higher concentration of glacial meltwater beneath the ice shelf. Funding for the Automated Meteorology Ice Geophysics Ocean System, AMIGOS, which collected the data, was received from the National Science Foundation in the U.S. The research was also supported by the UK Natural Environment Research Council, NERC. Thiago S. Dotto, Karen J. Haywood, Rob A. Hall. Ted A. Scambos. Yishi Zheng. Yoshihiro Nakayama. Shuntaro Hyogo. Tasha Snow. Anna K. Wallen. Christian Wild. Martin Truffer. Atsuhiro Muto. Karen E. Alley. Lars Baim. Guilherme A. Bortolotto. Scott W. Tyler. Aaron Pettit. https://ift. TT, F8 Galf 1. Access December 22, 2022. Thanks for watching. Please subscribe my channel for more videos.